All right, let's finish this up. We are going to connect marginal revenue to elasticity. We take the expression of marginal revenue and we write it as a function of absolute value of elasticity. That is the price elasticity of demand. Okay. All right. So just a reminder, the elasticity is expressed as a function of slope, right? Actually, elasticity is 1 over slope times P over Q. So working on your right hand side here, the slope is written as change in price over change in quantity, right? Changing the thing on the y-axis divided by changing the thing on the x-axis. Very good. Well, 1 over all of that is just the inverse. So change in Q over change in P times P over Q. And so we write 1 over the price elasticity of demand as change in P over change in Q times Q over P. Okay, we take that and substitute it right here for this stuff. And so this is what we have. Now, if you remember, I am using the negative sign right here. So I'm taking the absolute value of my price elasticity of demand to keep things consistent. In other books, they use a plus sign, but they use the negative version of the price elasticity of demand. It's negative. You can take the absolute value of it. Well, so this is what I'm doing in this video. Okay, now using this information about elasticity, we can draw marginal revenue. Now, if you remember, there's a pattern of elasticity along the inverse demand curve such that around the top of the curve, price elasticity of demand is elastic, and in the middle it's unit elastic, and towards the bottom it's inelastic, right? We use that information to draw, or we can use that information to draw the marginal revenue. Let's start with the unit elastic, the middle of the inverse demand curve. For price elasticity of demand, the absolute value of price elasticity of demand equal 1, or unit elastic, we can write marginal revenue as P square bracket 1 minus 1 over 1 equals 0, right? Because 1 minus 1 is 0, and so times P is 0. So marginal revenue is equal to 0 for the middle of the price elasticity of demand. So that middle can be projected down to the Q axis, so that we have marginal revenue equaling 0 right where I am placing the red dot on the graph to your right hand side. You see, so when I connect, we know the marginal revenue shares an intercept with the inverse demand curve, and so when we connect the two, the intercept along the price axis and the red dot, when we connect them, oops, hold on, let me do a better job on that. I think this should work. If it doesn't, we'll oops. Yeah. If it doesn't work, the third time is the charm, eh? Yeah. All right, good. So this is MR, marginal revenue. Right, so the top part of the inverse demand curve, where price elasticity of demand is elastic, you can see that marginal revenue was positive until we hit the unit elastic portion of the inverse demand curve, where marginal revenue attained a 0. And along the bottom of the inverse demand curve, we notice the marginal revenue is negative. Yeah. So for the elastic price elasticity of demand, we notice that our marginal revenue equals P square bracket 1 minus some fraction. Yeah. So 1 over price elasticity of demand, where it's bigger than 1, let's say 4, right? 1 over 4 will be a quarter, some fraction. So 1 minus some fraction, you will get a positive number. So margin times P, still a positive number. So marginal revenue is positive where price elasticity of demand is elastic along the inverse demand curve, right? Okay. For the portion of the inverse demand curve where we have an inelastic demand such that the absolute value of price elasticity of demand is less than 1, what is happening there is our marginal revenue is P times 1 minus 1 over some fraction, because price elasticity of demand less than 1 in absolute value, right, is some fraction. So 1 over some fraction is a big number. 1 over a quarter is 4. That's a big number, right? So 1 minus a number bigger than 1 is negative. And so price times a negative number, the whole thing is negative. And so marginal revenue is negative, which is why our marginal revenue is negative and falls below the Q axis right here on your graph. Right. Okay. The final thing we will do in this video is look at how we measure, the metric we use to measure the degree of market power that a firm enjoys or that a firm has. It's known as the Lerner index, and the Lerner index is such that, well, we have this, let's change color for a minute. We have, we use the profit maximizing rule, marginal revenue equal marginal cost. We take our marginal revenue expression and set it equal to marginal cost. So I got us started, and so let's work through this. P minus P over the absolute value of elasticity equal MC. I want P minus MC on the left hand side equal P over the absolute value of price elasticity of demand, and I multiply through by P. This is MC, and I multiply through by P so that I have P minus MC over P equal 1 over the absolute value of price elasticity of demand, right? And so I have the Lerner index that's calculated as P minus MC over P equal 1 over the absolute value of demand. Now, other books have this as equal negative 1 over, right, over this. Now, you know that I am using the absolute value, and so I'm going to get a positive number here, but you will get a positive number on this side too. Price elasticity of demand is negative times this negative number, the whole thing becomes positive, right? So other books have it this way. So this is in other books, just to let you know we are all saying the same thing. Other textbooks have it this way. Okay, so what is this? Well, the larger the Lerner index, which one is the Lerner index again? This part, this is the Lerner index. Lerner index. Right, the larger the Lerner index, the larger the market power. The larger the Lerner index, which is equal to 1 over the absolute value of the price elasticity of demand, the larger the index. The larger the Lerner index, the larger the power that the market enjoys. Pardon me, it's 10 p.m. Oh, 11 p.m. And yeah, well, we can make it. We're almost there. We are almost there. Okay, so what does this mean? Well, consumers, if consumers are more sensitive to price changes, then less likely the firm can take advantage of them. If consumers are more sensitive to price changes, the less likely the firm can take advantage of them. A firm that has more market power is able to set prices, right? A firm that has no market power, like perfect competition, the firms in there have zero market power. And so the Lerner index for perfect competition is 0, because price will equal marginal cost. you see. So, well, let's write that down. If consumers are more sensitive to price changes, the less likely the firm can take advantage of them. The larger the Lerner index, the larger the firm's market power. The smaller the Lerner index, the smaller the firm's market power. When we look at perfect competition for each firm, I hope you remember that there is a horizontal demand curve for each firm. If you think of that horizontal demand curve as almost horizontal, then that means that price elasticity of demand is just so big that 1 over that is super close to 0 or 0. However, for a firm like the monopoly that jacks their prices up above marginal cost, their Lerner index will be large. And so they enjoy, the monopoly that is, enjoys a bigger market power or has influence in setting prices in that market. Well, on that note, I will say good night. Like, share, subscribe, hype, and I'm out.